Thanks, everybody. Doug Sillers, thanks for the great introduction. I'm originally from Seattle, Washington, so I'm going to talk in English because I don't have a lot of Spanish, so thank you for listening to me in English. I'm traveling through Europe with my family, so I'm here with my kids and the dog, and my wife are back at our Airbnb right now. A little bit about me. I've been traveling with my family for 2 out of the last 3 years, but I'm doing freelance developer relations. So what that means is I help companies figure out how to talk to groups of developers. So there are a lot of companies that have awesome tooling and things like that, and they want to get developers to use it, and so I try to help them figure out how to do that. I also do a lot in performance. So I've been working for many years. I worked at AT&T for a long time, helping companies make their native apps and their websites faster. And I lead workshops on performance, images, and video. You're going to see a little bit about what I do for video today. If you have any questions, and you ever want to have any questions about any of this, I'm the only Doug Sillers on the internet. So Twitter, Gmail, website. I'll be posting the slides up on SlideShare/Doug Sillers. So when you think about video, and video on the web specifically, it's growing like crazy. You know, they say during the busy hour, Netflix is like half or 2/3 of the internet, right? There's a lot of video being transported across the internet. And you know, they're saying by 2021, it's going to be this huge percentage of the internet. And so we're really interested in studying how we can optimize video so that it looks great for everybody. Has anyone here used web page test? All right, I see a couple hands. If you haven't, it's a really awesome tool to figure out how fast your web pages are. You just type in your URL right here. You can test anywhere around the world. So you can test your website in Spain, you can test it in London, you can test it in Singapore, you can test it in the States. Here I'm testing in Virginia, and the reason I'm testing in Virginia is they actually have real Android and iOS devices there, so you can see what it looks like on a mobile phone, which is really important. You can also change the speed of your network connection. So here I'm forcing it on a 3G connection because, you know, much of the world is still on Edge or a really slow 3G connection. Earlier this year, I spent a month in West Cork, Ireland, and I was 2 hours west of Cork. That's how in Irish they say west, the further west you are. And my Airbnb said, yeah, we've got Wi-Fi. They didn't mention that it was connected to a 3G router that had Edge. So like slow websites were like my life for a month. And so it's really important to see what your website looks like on a slow connection. And then there are all these like tabs that you can do all sorts of other wacky things to change the way your website works and see how it goes.
What would be the benchmark here?
I'm going to show you some of the test results from web page test. It's not on this next slide, but we'll get to it. I'll show it to you. So what's really cool about web page test is that there's a group of folks they're mostly Googlers. They built the HTTP archive, and what this does is it uses web page test to scan. It crawls 1.2 million websites every 2 weeks, desktop and mobile, and then all the results are thrown in a database that you can query and learn like what's building the web today and what was building the web. And they do it every 2 weeks, so you can go back in history and just see what the web is built on. And so using that tool, I can see that on mobile, year over year, video's grown like 0.6%. And so they're only testing the home page, right? It's only testing, you know, bbc.co.uk or cnn.com. It's not testing all the deeper links in there. And you can see desktop is growing too, right? And there's a few more videos on desktop than there are on mobile. So when you think about video metrics, there are a few metrics that are out there on what makes a good video. And the first metric is, did it start playing? And then the second one is, did it stop playing when it was supposed to be playing? Did it stall? And the last one is, did it look good while it was playing? And these are really, you know, kind of a shorter way of the top metrics for building mobile, for building videos. And I talk a lot about optimization, how to deliver stuff to the phone, to the desktop faster. And it's my contention that if you optimize the way you deliver the video to the phone, it's going to start faster, it's not going to stall, and it'll probably look really good because you've optimized it so it delivers quickly. And I'm going to show some examples here. There's studies out there that show when people don't see a video right away, they get really, really angry and they get frustrated. And there's another study out there that shows when a website is really slow, 4% of mobile users admit to throwing their phones. And so that's why it's a cool picture of a screen anyway. So when we start looking at video startup, this is data from this year, from Q1 of this year. It's from a company called Conviva, and they're an analytics company. And so they were studying almost 17 billion video plays in the first quarter of this year. And they found that 400 million of those videos failed to start. You press play, nothing happens. 2%, like that's pretty bad. And then another 11.5%, or 2 billion videos, they press play, it was trying to start, but it took so long that they gave up. And so obviously, that's 800 million hours of video that were lost in 3 months, right? I don't even know if 800 million hours is 3 months. I should probably do that math, right? But it's a lot of hours. So what can we do to make sure that these things don't happen? I have a feeling that a lot of them is stuff like this, for the video failing to start. We've all seen this, right? You go to a web page, you're like, oh, I can watch this video, and then it's like, oops, sorry. And this is a horrible user experience. I use Amazon in America, and when I use Amazon Prime and I try to go to Amazon Video here in Spain or anywhere in the EU, it'll say, here are all the videos you can watch in America, but you can't watch them while you're traveling. But here are the ones you can watch. So I don't even bother clicking that link because I know it won't work. But here at CBS, when you click the link, you have to download, where did it go? This is Chrome DevTools, 231 requests, 3.1 megabytes of data to find out that you can't watch the video, right? That's a lot of data, especially on a mobile device. I mean, this was desktop, but you get the idea, right? It says it took 18 seconds, but that's because I was really slow with my screen capturing ability. I was too slow grabbing the screen. There was a ping in 18 seconds because they had analytics watching to see if the video was being watched. In this case, watching that the video wasn't being watched because it wouldn't work at all. So they're keeping on cellular, what that means is they're turning the radio on to make sure that people are still watching the video. When you're turning the radio on a mobile device, what's happening to your customer's battery, right? What do we do constantly with our phones? Like I'm plugged in right here, right? Because I don't want my battery is low. We plug in at work, we plug in at home, we plug in the car. We have battery packs to plug in when we're not in any of those places, right? Anything we can do to conserve battery life for our mobile users is really a thing to think about. Okay, so we know that these 11.5% of videos didn't start. And that same study shows that in Europe, the average video takes 4.3 seconds to start. There's a lot of data hidden in 4.3 seconds, right? That's mobile phones, that's people on fiber connections, that's people on 2G, 3G, 4G, right? There's a lot of people see it really fast, there are a lot of people see it really slow, and they just threw all those numbers together and gave us one answer. So we know that there are people who will never get to see videos because they're trying to watch it in a really rural area on top of a mountain with a low-powered, cheap Android device. It may just never work, but most people should be able to see a video. This is another study. Akamai did this study, and they found that people will wait 2 seconds to watch a video. If you hit play, everybody just about waits 2 seconds. But after 2 seconds, you lose 6% of your users every subsequent second. So you start losing your customers really, really quickly if the video doesn't start to play. And that might be why we're losing 11.5% of our customers. People will hang out for different amount of times for different types of videos. If it's a short video, they abandon faster. For example, if you click on a video of a cat wearing a shark costume on a Roomba chasing a duck, after 2 seconds, you're like, what the hell did I click on? And you stop because you're, wow, what am I wasting my time doing here? But if you're watching a movie or a TV show, you're going to hang out, right? Because you're already going to hang out for 20 minutes, an hour, 2 hours, whatever. You're more willing to wait for a video to start. But what are the things that lead to video startup delay? And I'm going to walk through a couple of, well, first, let's look back at the HTTP archive. And this is 500,000 websites, 36,000 on mobile, 55,000 on desktop have video on their home pages. If we look at the intersection point, if I can use PowerPoint right, 30,000 overlap, right? That's kind of expected. If you've got it on your mobile site, you probably have it on your desktop site. So I want to look at a lot at these 30,000 websites and see what they're doing to make sure the video looks great on mobile, but also looks really good on desktop, because those are obviously two different environments for browsing video. And that's 83% of the mobile videos. There's 185,000 mobile video requests. But 21,000 sites use the same video on desktop and on mobile, right? So it's the exact same file, right? So either it's going to look really, really good on the desktop and be really, really slow on mobile, or it's going to look really, really good or it's going to load fast on mobile and look really crummy on the desktop. It's going to look great on the desktop and be really slow on mobile. And if you start thinking about how most websites are 50-50, if not higher, mobile usage to desktop, that's important to think about. 19% of all of the videos on mobile were identical, exact same movie, and they're not testing on the same day. When HTTP Archive does these tests, the mobile test may be run on Tuesday and the desktop test may be run on Thursday. So sites that change their video on the homepage a lot, we wouldn't see this. So these are just web pages that have a video on their homepage for days and days and days at a time. So, like I said, does it start, does it stall, does it look good? I'm going to talk a little bit about image optimization as sort of a proxy for video. And this is my goat, Josephine. We have goats back in the States. When you optimize an image, there are a lot of different things we can do to make the images smaller. And basically the idea is make the images look good, but make them small enough that they download fast, because the faster it downloads, the more interested your customers are. But also make sure that it still looks as good as the original image. So this image of Josephine was 2.5 megabytes. There's a thing called, you can save images at different quality in Photoshop and tools like that. Google recommends 85% quality for all images that you put on the web. There's a way to get even better, and it's called structural similarity. And if you're interested, we can talk about that afterwards. It just squeezes out a little bit more compression. And when I do that, I get it down to 1.28 megabytes when I use structural similarity. The next thing I can do is, I was testing on, and I was using a tool called Cloudinary. You upload the full-size video to their cloud tool, and then I just put Q Auto, and it builds this 1.28 image for me on the fly. So it's kind of neat. Image format, I save it as a WebP. WebP is used on Android, it's used in Chrome. It is coming soon to MS Edge and is in development for both Firefox and for Safari. So it may be on most modern browsers by the end of the year or soon after. I squeeze out another 40 kilobytes. And then responsive images is the idea that you size the image appropriately for the device, right? So this image was probably 13 or 14 megapixels on my phone, but it doesn't need to be that big to show up on the screen of my phone. I made it 1,400 pixels wide, and I shaved off, a megabyte. So now 200 kilobytes is going to download, at least 10 times faster than 2.5 megabytes. So what I've done is I've lowered the quality to where the human eye cannot tell a difference. I've resized it, and I've used the right format, and I've made the image a lot smaller. We can do the same thing with, so when we look at all of the websites out there, this is the percentile, and this is the number of megabytes per page. So at the 95th percentile, we have mobile websites that use 6 megabytes of images. Imagine how long that's going to take to load on a website, right? But what we see is mobile is usually lower than desktop, so that's good, right? The images should be smaller on a mobile device than they should be on the desktop. We're doing the wrong thing for video. The first thing to notice is the scale. Whoops, sorry, I went the wrong way. We go from 7 megabytes to 70 megabytes, right? So our scale is 10 times bigger. But we can also see out here that mobile websites are using more data than the desktop. We're sending more video to mobile than we are to the desktop. And so that's probably wrong, and we should probably look to see what we're doing wrong so we can optimize it. And we can also see here at the 95th percentile, we've got websites sending 50 megabytes of video to mobile devices, which is kind of crazy when you think about it. So let's figure out what we can do to optimize that. The cool thing about video is, this is Nora. This is also one of my goats. The cool thing about video is that video is like images, except for you've got a time function, right? You've got height and width, and then you've got time. And then you also have an audio channel. So it has added complications from just images. So let's look at what that looks like. The great thing about video is it can compress through the time dimension, that third dimension of time. And so they call it a group of pictures. And so this is a full image. The other green one is a full image. These P frames are about half an image. And then the B frames are 25% of an image. And they use all these vectors to figure out where the colors go. And that's how we get compression through that third dimension of time. And we can look at that. So I've got a video of Nora eating a leaf.
And every how many seconds are those images?
That's a good question. It depends. You can do different types of compression. Sometimes I think most of them have 16 frames in between each iframe, but some go 24, some go, so like every single different compression algorithm is slightly different.
I heard that there is a limit at which the human eye starts seeing.
You start seeing it, yeah. Yeah, so there's a lot of work being done on this right now, and I usually just go with what the defaults are in the encoders because they're pretty good at. If you go higher and you start lowering the quality, you start to notice it. So, there's pretty built-in compression. And obviously, just like there's new image compressions coming out, algorithms coming out every year, there's new video compression, VP9, H265, there are all these new video compressions that are coming out to improve these things every year. But these are the P frames, and so you can see the vectors drawing like how this is being optimized. And then you can see the B frames, because they're more often, right? You can see there are more of them. And so when you put all that together, you can see all the compression that's happening through time. And that's what's making this video smaller rather than just having lots of discrete images. If you want to talk about discrete images over time, you get to the animated GIF. So that movie was 1.4 megabytes. But if I turn it into an animated GIF, there's no compression through that third dimension of time, and it's 3.8 megabytes. So when you put an animated GIF on your web page, it can actually slow, it's obviously a lot bigger. It's also 256 colors because it's from the 80s. That's when they built animated, the GIF format came out. And there's none of that group of pictures compression. So it's just literally, you can actually strip out and see all of the images. If I make it into a video, 256 colors, and strip out the audio channel, it's 250 kilobytes, which is obviously way, way smaller. And I can put it in a video tag in HTML. Loop, autoplay, muted, play the goats, and it'll just loop. And that works. You have to say muted on mobile, and that's what saves us in meetings when we're supposed to be paying attention and we're browsing the web, because if it plays loudly, we'd all be found out that we were watching movies. But video is the last thing to load. Browsers know that videos are big, so if that's at the top of your page, this is going to last thing to load. That may not work for you. In Safari today, you can actually put a looping video in the picture tag. And so if you built this picture tag for your Mac, your Safari users, for your iOS users, it would load that 250K video and loop it over and over again. For your Chrome users, you could have an animated WebP that's 3 megabytes, and then you have the animated GIF for everybody else, 3.8 megabytes. You can see that your iOS users are going to have a much better experience because that thing is going to load 10 times faster, right? 250K versus, actually, I think I have the stats on the next page. I don't. I've got them somewhere. Anyway, so if we look at the different types of videos that are out there on the web, most of them are MP4s. And then we've got some streaming, the TS files. And I'm going to focus on those for the rest of the talk, how we can optimize MP4s, how we can optimize streaming to our customers. This is Major League Baseball in America. You know, baseball is a sport that a lot of people follow. This is the desktop page. This is the mobile page. This video and this video are identical. Same videos downloaded, mobile and desktop. It's 17.6 megabytes, according to Chrome DevTools. And we can learn a lot about this video. It's 17 megabytes. It's 960 by 540. It's 83 seconds long. And it's at 1.7 megabits per second. It's basically a minute and a half recap of a baseball game, right? So it has all the highlights. It describes what was happening. Great. You know, that's a great thing to have on your web page. But how can we optimize this? What can we do to make this better? What if we downscale it to a lower bit rate? If we downscale it to a lower bit rate, and again, I'm using a cloud-based tool to do that for me just by setting this auto quality. What that does is it lowers the quality of the video to where people don't really notice. It lowers the audio from 44 kilobits per second to 22. I mean, it's an announcer talking about a game. It's not like you need, you know, high quality audio for that. And I get 22% savings, right? It's 13 megabytes. So think about the savings there. That's going to download a lot faster to both desktop and to mobile. No one's going to know the difference. And another thing to think about is when you're building this and you're serving videos out of your infrastructure, you have to pay for every megabyte that comes out of your back end, right? So if you serve this one 1,000 times or this one 1,000 times, you're using a lot less data. It's going to save the company money. You could further make a mobile version and, you know, it'd be just downsize it, downscale the dimensions, and it's 62% smaller. So 50% of your users would see this, 50% would see that. The savings of both the data out of your servers and for your customers is going to be a lot better, and they probably won't even ever notice a difference. This is a web page. It's still live today. I tested it last week. But when I download the website on desktop, it's 267 kilobytes of video. When I download it on mobile, it's 500 kilobytes of video. They're downloading more video to the mobile device than they are to the desktop. Why are they doing that? Well, we can actually look. This is a waterfall diagram. So one of the things in web page test you were asking, it gives a waterfall of everything that was requested at what timing. And you can see that there's 4 videos that are requested. And on mobile, they request the Retina versions, the 2x. Right? So the videos are twice as big because they're using a Retina version of the video. And you can see that in their HTML, right? If the class is Retina, serve this one. If it's default, serve the regular one. But they're using CSS on this page, and they only show videos if the screen is 1,000 pixels wide. So what happens is they download these 4 Retina videos. The screen is not 1,000 pixels wide, and the video is hidden from the user. So it's 500 kilobytes that's downloaded, slowing down the load of the page, but no one ever sees it. And so that's obviously not a great experience for the end user. So this is another waterfall diagram. And so, you know, when you build a web page, you've got your HTML, you've got your JavaScript, you've got your CSS, you've got all that stuff. And so you can see each one of these lines is a different thing. And the idea is you want a straight down waterfall. The more horizontal things are, it's not a waterfall and it's going to be slow. One of the things you can do when you want to have video on your web page is you can set the preload equals auto. And what that tells the browser, it says, download this video no matter what. And download it, it will, right? That's like, I think, what was this one? 23 megabytes of video. We're down. This is 23 megabytes here, and the rest is just that little bit of the pie beforehand, right? So have you ever been on your phone and you're going through a web page and you're like, oh, there's a video. It's like, oh, I'm on mobile. I don't need to watch that video. This web page decided for you. It downloaded it for you whether or not you're going to watch it or whether you were going to watch it or not watch it. So my recommendation is don't do this because it's downloading the entire video to everybody. So again, you're paying for all the costs coming out of your server if you're hosting this. it's downloading 23 megabytes every single time. I mean, if someone's going to watch the video, if you're sure that 90% of your viewers are going to watch, people hitting this page are going to watch the video, download the video, sure. But if it's going to be 10% or 5% or even less, don't even worry about it. Don't download it.
But can you make like from each video to be split in parts?
Yes.
And to load first bit from any video, and if you click on one, another to
yes. Yes.
load the other.
The next thing you can do is you can say preload equals metadata, and it'll download on Chrome. It downloads like 3% of the video. And so what that gives you is it gives that first couple seconds, first half a second of video, so it's there, it'll start quickly, and then it can start downloading the rest when they press play. And that's default for Chrome. If you don't set this, it will download a little bit of the video. It could. But people, again, remember, they'll give you 3 or 4 seconds when you hit start, when you hit play. So if you have a little bit, the radio is already on because the page is loaded, so it'll download the rest of it fairly quickly. You've got a little bit in the buffer. However, in this case, I see one request, right? That one video. This is the video file right here, this big giant download right here. And you can look at all, you can see images, JavaScript, there's one video. But that one video request is 2.7 megabytes for every single time the page loads. So in general, it's a great idea, but for this page, it wasn't so much. And the reason it was so big is the video is 2.5 minutes long. It's 1080p, and it's 97 megabytes. So the problem here is probably not the preload equals metadata. It's the fact that they have a 97 megabyte video on their web page, right? Further, let's see where that shows up on your mobile site. So this is the web page. That's the first 1, 2, 3, 4, 5, 6, 7 screens. 8, 9, 10, 11, 12, 13, 14 screens. There's the video. Way down here, how many people are going to scroll to the bottom of this page to even see that there is a video? Nobody. Nobody's going to get there on their mobile device. So in this case, they probably shouldn't have used preload equals metadata. They should have not downloaded it at all. And they've actually fixed this. They're not downloading it at all anymore, which is good. Because really, you should just think about your customers' data plans. Like, people are going to see your web page on mobile. So just think about, like, do I need to download this giant file? I've got a lot more examples that are really awesome that will hopefully get you thinking about that. So you've got preload equals auto or metadata. Avoid auto unless you think they're going to watch it. Metadata, medium probability, but your mileage may vary. So, I mean, test it. See what you think is going to happen. Background images. How do you guys feel about background videos on web pages? Guys, how do you feel, like, as a user, how do you feel about background videos? Is that something that you like? So the research out there...
Very much about what's the website.
Right. That's where I'm at, but research shows that people are 80% more likely to stick at the web page if it has a video in the background. Like, people really, from a marketing perspective, it really, really makes sense. This is not going to have sound because I think it's routing through my mic, and so it's being recorded for the screen recording. But this is the background video for that thing. And if you could hear it, there's a guy doing a voiceover talking about how awesome this place is for kids to come play. Now think about a background video. What do you never hear when there's a background video? There's no audio when you have a background video. So this is a 5.3 megabyte video. It's 15 seconds long. And we can look at it. We can see there are 2 streams. And one of the streams is video. And so you can see it's 720, 1280 by 720. It's H.264. We can get all this information about it. But we can also see that there's an audio track. And if there's no audio track and you're not going to hear it, if a video plays and there is no, and it has sound but no one hears it, does it really have sound? In this case, it really did have sound, and it was 5% of the file. So if you just strip that out, you obviously are going to make the file smaller. It will download faster, and people can enjoy it faster. So to save bandwidth, remove the audio stream from files that are played silently. And honestly, I wouldn't have found this video, if it wasn't called Steven. Like I was looking through all the data, I'm like, why is there this video called Steven? I'm gonna look at this one. And then I caught that it was a background video and they screwed it up. So if you want me not to find it, use something like Hero Video or something really, you know, innocuous so that I won't go and look at it.
Sorry, just a quick.
Yeah, go ahead.
How do you get those information usually?
Okay, so I was using the HTTP archive, and so it tells me it knows all of the requests in and out of 1.2 million websites, and so I looked for all the MP4s. And so then I had all the MP4s, and they're all in a table, and I can rank them by size, and I can look for the websites that are doing wacky things with ginormous videos, and then from there I can work backwards. And there are a lot of them, as we'll see as I go through the talk. But, and then this is a tool called FFprobe. It's part of FFmpeg. And so you can do a show streams of any video, whether it's local. In this case, it was local, but you can also put, you know, a URL in there, and it'll look up the data about any one of those. And so in some of my future things, some of my future slides, I had a list of 14,000 videos, and I'm like, I wonder what I can learn about those videos. So I just ran a curl script, and I got this information about 14,000 videos, threw it in a database, and then I can query on it and figure out what's out there on the web. Actually, this all just went into a CSV, right? So that row 1 or column 1, 2, 3, 4, and then I could just sort it and do, you know, Excel science on it, basically. So here's a waterfall diagram of and this is that same web page, and you can see these two green video files. So that's the same video file, that's Steven being downloaded on mobile. But again, they don't show the video on mobile. They put a placeholder image there. So they download that entire video on mobile and then don't show it to anybody. Right? That's just hurting, A, the data coming out of your network. It's hurting your customers' data plans. It's wasting their battery life. Like, there's just numerous reasons why you shouldn't do that. So if the viewport isn't going to support video, just don't download it. Today, if you want to serve different size videos to different devices, you have to use JavaScript anyway. So why not have JavaScript that says, if it's this small, don't. If it's this small, serve small, medium, large, or however you want to divide up the videos. And then you can just show the right videos. This is a website from America. There's a background video of this lady, and she's playing with her granddaughter. In this video, we're going to learn a couple things. One is Bob Ross also is a photographer. But this video, this background video is 33 megabytes. If I just pull the URL and try to watch it in my browser, it stalls just trying to watch the video. It's so big. How big is that video? Well, it's 27 seconds long, and it's 2,500 by 1,200. This video is ginormous. And it's 10 megabits per second video that they're trying to stream in the background to make it look great. And so I think the advice here is, remember that when you're building a web page, everything is stored locally in your cache on your computer. So it may look great on your machine, but test it out on some other machines that may not have it cached, or clear out the cache, or use dev tools to pretend that the cache is empty, just to see what this looks like. You should probably resize this to something reasonable, because that's bigger than most desktop screens. A tip, if you rename the file to 720p, that doesn't actually resize the file. But it's new. It's like they were trying so hard and it just didn't work. If I do resize that file, right, if I make it 1080p, if I make it 720, right, these are reasonable. They're big, but it's not 30 megabytes. That's going to download, that's going to play on mobile, it'll play on desktop. All right, and then again on mobile, it got to 17 megabytes on mobile before the browser's just like, I'm not going to be able to download that whole thing, and it gave up. But now we can watch the movie, And so this is the movie as it plays, and I think it's New York, I think that's the Brooklyn Bridge, and she's, you know, whatever. But right here, the video starts over again. So it's not actually 27 seconds, it's the 13-second video twice. And they didn't compress it because it's that big. I think actually when I did, I'm going to go back a slide, it's just going to take a second because my computer's slow. I think when I did this compression, the tools realized, though, the second 13 seconds are exactly the same as the first 13 seconds, so that's one of the reasons I got so much compression out of it. But yes, indeed, don't duplicate the video in the loop, or if you do, make sure you use a compression that just like gets rid of that and does it, you know.
Is that with Cloudinary?
I did use Cloudinary to compress it there, but you can use any tool. You can just change the size, but yeah.
I use Cloudinary.
Oh, you do? Okay.
I didn't know those tools were.
Yeah, so you can do it with video, and so so you use it for images, I assume, right?
Mostly.
Yeah, so when you do a change in Cloudinary for images, you can change the width, and it does it like in like 100 milliseconds, right? Because it's just resizing an image. Video takes a little bit longer than that, so it may take, so you want to hit all of those URLs to make sure that it generates them before you put it live, because it could take a minute or two to create. Video just takes a longer time to reevaluate. But it will resize video and do all the same things that you love Cloudinary to. So the reason I talk about it is it's a great tool and it's really easy to use to optimize images and video. All right. So this is another mobile background where it downloads this whole 30 megabyte video in the background for the background video. And when I see this in web page test, I've taken this, and I see it on a mobile site, I've taken this to be I call it the mobile middle finger, because you're just like, how do you feel about your customers on mobile? Well, I feel like they should download something that big all of the time. And I really think you should use a different video for mobile than you do for desktop. So far, if you have a Retina, be careful about Retina on mobile. If you're not going to show the video, don't download it. Preload equals auto metadata we talked about. If it's silent, don't download the audio. Don't duplicate video traffic, and really just think about your mobile users, which is kind of the ongoing theme here, right? Think about your mobile users. Video streaming, so you talked about how can I cut it up in different ways. Video streaming is another way to do that, where instead of one file, you break it into 4 or 10-second segments, and it just sends down 10-second segments. And the other great thing is you can have different bit rates. So you can have a really high-quality bit rate, a really low-quality bit rate, and the player will say, this is a smartphone, it's a small screen, it's on a crappy connection, low quality. Or it'll say, 100 megabit Wi-Fi, big screen, send down the high quality, and it all sort of works its way out. The player has to know what's available, and the first thing you send is a text file called a manifest file. Here's what we have. It's like the menu. And the player chooses one. It starts downloading the segments, and ideally, the buffer starts filling up, and the video plays. That's what we want to have happen, and we want that to happen for everybody. And then once the video starts playing, the player can see if the network throughput is bigger or smaller, and it can change the size of the video depending on what the network can allow and give you the best bit rate for that user. It may not look great if they're on a poor connection, but it won't stall. It'll just keep playing in a way that looks great. When I test with the HTTP archive, they throttle all mobile to 1.6 megabits per second and all desktop to 5. So when I show the data and there's a discrepancy there, it's because they're testing at different speeds. This is a manifest file, and this is HLS streaming. So HLS is kind of what Apple uses today. Everyone says that MPEG-Dash is going to take over in the next few years because it is an internet standard, but today most video streaming is HLS. And so we can break this into a couple different steps. Video tracks inside iframes. They have it separated. And then these are all the audio tracks and the subtitles. And so this is from a TED Talk. And you guys know TED Talks, right? And what's great about, what's cool about this is the video track. And if you have multiple audio tracks, you could say, oh, Spain, ES. Oh, UK, GB, right? You can serve the right audio track to the different person. And then low battery. Let me plug in here really quickly before, because that would be horrible, wouldn't it? What? Too many videos. It is. It certainly is. I see a plug right there, so we're good. All right. I'm also charging my phone, so I'm kind of, being super inefficient. All right. It's going to keep working. Oh, and I'm recording the screen so they can post this up on YouTube later. So it's like I'm just doing everything using just a lot of power. All right. So the other cool thing is these are all the, so you can do different, you can have different audio tracks for different localities. And then they also have all of the subtitles. So you can choose the different subtitles. And what's really interesting about this video to me is that the guy is speaking in Japanese. It's a Japanese TED Talk. But it's like, I don't know if I can read it here, but it's like Greek, Turkish, like Japanese isn't the first subtitle, English isn't the first. It's like these weird, and because it's basically the player just lists them in order. So if you put, Estonian at the top, that's going to be the first choice for people. And it's like, does this Japanese guy have a lot of Greek followers, and that's why they put it at the top? I don't really know. But what happens when you download a manifest file is you can see it shows the bandwidth, the ID. It says use this 600K audio file. Gives you the encoded, the codec, the resolution, and then this is the file. These are the files to download for this bit rate, right? And so we've got bit 1.4, 220 kilobits, 587, 931. You can see, there's just different bit rates available. The player always picks the first bit rate. That's just, by default, it picks the first one. It's got to start somewhere. It picks the first one. And so in my theory then, if we see that same one, if we see on mobile and desktop the same bit rate, that's going to be the first stream that's played. And we can actually look at that. I can find 1,900 of these TS files, so those are the streaming video segments, that are identical on desktop and mobile. So we can say, what are the initial bit rates? And we can see that in general, they're pretty low. And that's good, because a low bit rate means it's going to start up quickly. We know that's one of the first things we want it to start up fast. And it'll start up both on mobile and desktop. But we do see there's a big chunk of people starting out here at 3 megabits per second. And if we know the mobile tests are run at 1.6, these aren't going to stream on mobile. Actually, none of those are going to stream on mobile, right? We know that based on the way these tests are being run. So we can see the initial bit rates are in green. Mobile actually gets a little higher here, right? So this is all of the other TS files afterwards. We can see on desktop, there's actually some streaming out here. The bit rate gets higher. We see, there's a little mound right here out at 1.5 megabits per second where there's some desktop streaming, so the quality improves on desktop, as we might expect. Yes. Yes, so there are a lot of mobile. It didn't start there, but it ended up streaming there afterwards. So were those ones out here that dropped lower, or ones that were low that went higher? I don't have all that data. I didn't slice it and dice it a million different ways. So we don't really know. But what happens when you select a high bitrate stream, right? One that we know isn't going to play. The player starts downloading it, and it takes a long time. And the player knows that if it takes a long time, people are going to leave. So it switches to a lower bit rate and then starts streaming. Then the buffer starts filling, and indeed the video starts playing. So we can look at how that works. And so one reason why people may give up is it's trying to download a big bit rate. It doesn't work. The player tries something new, but by then your customers have given up. So if you organize your bit rates low to high, right? So this is the first bit rate. It's going to start downloading this, 200 kilobit per second video, and it's going to start playing really, really quickly. It's going to be really low quality, but it's going to start playing. And then once it starts playing, the player knows, gets an idea of a better bit rate that it can choose, and it may end up at bit rate 4, like this, you know, I don't even know what that is, 3 megabit per second video, right? Just because it can do it. If you start off high, the player can't do it. It gives up. It goes down to this low bit rate, and then ends up in the middle. Well, that added step is going to make the video start up more slowly. And then this is what Amazon does. It's the Goldilocks approach, where they start with a middle-sized bit rate at the very beginning. And so if we think about this, you've seen this, where you start watching a video on your phone, and it's really pixelated, and then it gets sharp 4 or 5 seconds in. Netflix does it. A lot of different companies do that because it starts up fast, and then it looks good by the time 4 seconds rolls around. That's probably when the content's actually starting, right? The first 4 seconds is like intro music or something. Amazon is generally long play shows, and they know that people will watch a little bit longer. And so when you watch a video on Amazon, it starts up and it's beautiful from the very beginning. There's none of that pixelated stuff for the first couple seconds. So people who watch Amazon videos may actually like that because there's none of that like, why does it look weird? Oh, now it looks good. You know, it always looks good from the very beginning. We can look at this. So one thing Web Page Test does is it will take a screenshot of your screen every 1/10 of a second. I've got it out to every 1 second here. If I start off at the lowest bit rate, the video shows up on my screen at 11 seconds. This is on mobile 3G connection. If I start out at the high bit rate, it's trying to download that high bit rate. It gives up, it goes to the low bit rate. This video is the exact same quality as this one here, but it took 6 seconds longer for it to show up on the screen, right? And if we know that we lose 6% of our users every second, like we've just lost 35% of our users for the exact same content here. And then you can see, like I said, the Amazon example. It takes a little bit longer, but this is a lot better video than that one is over here. So again, this is one of those things you can test, figure out what your different types of users will use, but this might actually work if it's a long play video. I wouldn't recommend doing this because if you're on a slower connection, it's going to take even longer for the video to show up, which means you're going to lose more customers. So again, if you start at a high bit rate, if you're on a fast connection, you're in your office, you're connected to gigabit fiber, you've got a fast computer, you hit play, that video is going to look awesome every single time. But as soon as you go out and you turn it onto your phone, even if you're on really fast Wi-Fi, you're going to get a low initial quality. It's going to be very slow to start up. You know, up here, if you start with low quality at the beginning, it's low quality at the beginning, but it's really fast. And then in the middle, you sort of have this in-between quality. It's a good quality, but it's not too fast, not too slow. So there's, you know, this is one of those things that you have to test, but this is sort of where I see the layout is for starting up your video, and you know, you can work with that. When you load the TED Talk, it's really cool. I mentioned that there's the video track, the audio is in gray, so you can see it's video, audio, audio, video, audio, audio. You can see it all downloading back and forth, back and forth. And so in this case, you can, you know, specify your different languages, which is kind of neat. But I noticed something really weird with this TED Talk video. It starts off at a high bit rate and then drops to 64 kilobit per second and never recovers. And it should do better than that. I'm testing at 1.6 megabits per second. So there are a bunch of streams here that it should be able to serve a better video than it actually is. And what I'm showing here is these are all different segments of the video. These thousands, that's the intro. When you play a TED Talk, there's like an intro thing. They programmatically add that to the beginning of every manifest file. So if they ever want to change the manifest, they just change a parameter in the URL and it's a different intro, right? It's super simple. Like it blows your mind. They don't have to re-encode all the videos. They change the parameter on the URL and this goes away and you have a new intro video, which is kind of like, whoa, that's super cool. But it never recovers. It stays at 64 kilobits per second. So what happened? Why is that going on? I wanted to figure out why this video was acting weird. And that first bit rate is 1.4 megabits per second. But if you look, they're serving 600 kilobit per second video. So they're overestimating the video by like 150%. And so they're being conservative. And the idea here is if the player thinks it needs 1.4 megabit connection and it downloads at 600 kilobit per second, the buffer will never run out, right? It's just going to download it and it'll never stall. So that's great. It's never going to stall, but they're also artificially lowering the quality of the video for a lot of their users. So it's that balance is, does it stall or does it look good? And in this case, the player is conservative and the manifest is conservative. And by piling that on top of each other, the customer is getting a really poor video. The other thing that's interesting is they call the audio track 600 kilobits per second, but it's really only 64 kilobits per second. So they're overestimating the audio track. So the player thinks it needs to download 600K of audio, 1.4 megabits of video, but really it's a lot less than all of that. It's like 700. So they're being so conservative, they're actually breaking the way it looks. So, yeah.
From a user perspective, perhaps they think the actual sound is more important.
The sound, correct. But they're saying the sound is 600 kilobits per second, but it's only 64. So when the player is trying to balance all of the different things that it can download on the network, it's and you're right, it needs to download the audio for sure. But if you're overestimating it by 10x, you're going to lower the quality of the video. And maybe that's okay for them, right? But they're way overestimating the video too. And so they're just kind of throwing all these different things at the player, and it's sort of breaking. When you look at it 64K, it's really fuzzy. And so I wanted to figure out why it was, if they could make it better without impacting the audio, without impacting the video. And so what I did is, I rewrote the manifest file. So if this is 600K, I made that 600. And if this is 64K, I made it 6400, right? I just went through and rewrote it. And the great thing about this is I can host this manifest file on my server, but still have all the TED stuff on their server, and it just works. It's just like magic. The first thing to notice is the y-axis. It changes by a lot, right? I just changed the y-axis by, down the y-axis now only goes to 1500. And what's cool is it still drops to a low bit rate, but it catches back up. So that's great. Like the beginning, the intro looks bad, but it's by the time the video starts playing, this is the guy walking out on stage, and by the time he starts talking, it's great.
The actual quality of the video lowers at the beginning?
It does. It does. So in this case, it did. It dropped from 600K to 64K, and that's my next bit. Like, why did it drop? It should be able to play 600 kilobit per second video at the quality that on the network I'm testing on. It should be able to work, and it sort of does that. But and then eventually it goes back to the beginning. So this is the manifest file of each segment. So it says I want this segment, and then this segment, and this segment, and then all of these. And this is the intro, that thousands intro. I was like, well, it's getting screwed up on the intro. So why is it getting screwed up on the intro? And there are a couple things here. The first thing is it says, all right, this first segment is 5 seconds long, 5.0417 seconds long. And you can look, it's 9,700 kilobytes. Or, sorry, 972,000 kilobytes. And then they say this one is 6 seconds long, but it's only like 100 kilobytes. Or even less, it's like 30 kilobytes. So the math isn't right here. And then this next one is 0.1 seconds long, but it's like 1K or something. So the numbers are off. They screwed something up in this math. And I tried to go through and fix the math so it would work right, but it kept stalling. And then I was like, to heck with it. Let's call the whole thing 11 seconds long and just download the whole intro in the first segment. And when I did that, it never dropped. So somehow, by misstating these numbers in here, it was messing up the player. So they're being super conservative, and then they were somehow misencoding this information. And when I fix all of those things, it starts at 600 kilobits per second, and then the rest of the video is seen at 950. So it's a much better experience When I tested this the first time, it was at 64K all the way down. So by optimizing it, I mean, I probably went too far. I'm not being conservative at all, so it may increase the number of stalls. But obviously, there's a place in between these two places where there's a sweet spot where you still get good quality video and it's not going to stall. The next thing I'm going to show you is the Spengler. And you guys know the movie, yes? You know the movie? It's Ghostbusters. It's Ghostbusters, and there's audio, but it's not going to play. But this is the first time they fire their proton cannons. And he's like, the most important thing you can ever do is to never cross the streams. Because if you cross the streams, it will cause the end of humanity, right? All of the universe will come to a singularity and we're all going to die. Here's a web page that downloads 2 TED Talks at the same time. So it's streaming 2 TED Talks at the same time. It's trying to balance the network and try to get the best quality video, but it's trying to download them both, so they both come down at a lower quality video. So if somebody actually tries to watch the videos, it's not going to look as good. If they had just downloaded one, you get it up here at this much higher quality video. I've seen websites downloading 3 videos simultaneously in the background. Whether or not you press play or not, it'll all be there in case somebody wants to watch one of those 3 videos, right? So it goes back to respect the usage of your, the data usage of your customers. But also, if you want it to look really good, don't download all 3 at once because it's going to be a very low quality video. So don't cross the streams, only download 1 at a time. So basically, in conclusion, video files are really big, and if we can make them smaller, they're going to look better on mobile devices, they're going to look better on desktop, they're going to download faster, and people will be more engaged. There's a lot of data out there that shows the faster a website or a mobile app is, the more engaged people are. And when people are more engaged, they spend more money, they come back, they use your website or your app more often. Like all of the things we want to have happen so that we can keep our jobs building awesome tools, right? If people stop buying stuff from the company we work for, we're probably not going to be working for that company much longer. So resize videos appropriately for the screen with the quality, the bit rate, and the dimensions. Don't download hidden video. Don't preload it. Strip out the audio if you can. Streaming, start at a lower bit rate for faster startup. Start at the medium bit rate for that Goldilocks, the Amazon approach. Even out your bit rates to prevent stalls. There are ways that if you have big jumps in bit rate, it'll end up creating stalls. I forgot that slide. I cut it out of the talk. Use the right bit rates. Don't be too conservative in your bit rates because you're actually going to lower the quality to offset the stalls. That's what I was showing with the TED Talk thing. And then obviously don't cross the streams, 1 video at a time for best quality. And then really it all comes down to if you're serving video onto mobile devices, just like think about what somebody with a limited data plan or someone in a remote area might actually see when they're trying to use your app or your website. So with that, I'd be happy to take any questions. We can chat about video and all that stuff for a little bit. Thank you.